Today, I'm going to show you how to write your first Ethereum smart contract. We'll create this simple counter smart contract with the Solidity programming language. We'll do it all in your browser so you don't have to install anything on your computer. And you don't have to know anything about Ethereum, Solidity, or blockchain in order to get started. I'm going to walk you through step by step. So before we get into that, be sure to subscribe to this channel if you haven't already. Click the like button down below. And if you're serious about learning blockchain, then you need to join my free training on my website over at dappuniversity.com/bootcamp. In order to follow along with me, head on over to remix.ethereum.org to get started. So Remix is a browser-based IDE that allows you to start writing Ethereum smart contracts without having to set anything up on your development environment. You can do everything in your browser. You don't have to get anything installed, okay? So I'm going to go ahead and get started by clicking Solidity. That's the programming language that we're going to use to write Ethereum smart contracts today. So click Solidity. And this is going to give you a fully fledged development environment ready to go out of the box with Solidity. It even comes with a blockchain that's going to run in your web browser, so you don't have to connect to a public blockchain and you don't have to install a blockchain on your machine at all. Although I will show you how to do that at the end of this tutorial, so stick around. Okay, so I'm going to go ahead and click on this little file icon right here. This is the file tree that shows you where you can actually create new Ethereum smart contracts in this browser-based IDE. So there's already a file here called untitled.sol. You can create a new file if you don't have one. I'm just going to do this, right? So here's where we're going to actually start writing the code for the Ethereum smart contract. So I'll start off by creating the declaration of the Solidity programming language that we're going to use. Excuse me, I'm going to declare the version of Solidity just like this, say pragma, Solidity, version 0.5.1, all right? Some people do this with a caret. But I'm actually going to lock the version of Solidity so that we know the exact version that we want to use. And sometimes this is actually a security vulnerability because people could use higher versions of Solidity that might actually have a security vulnerability that you don't want your app to be exposed to. So that's just a little tidbit for you. And we can create the smart contract like this. We just say contract. It's a keyword in Solidity. And we give it a name. I'm going to call it counter. And then we follow that with some curly braces, open and close. All right, it automatically closes the curly brace for us whenever I hit enter. So all of the Solidity source code for the smart contract is going to go inside of these curly braces. The first thing that I want to do is create a variable for this counter smart contract. I'm going to call it uint count. All right, so let me explain what this means. This is a variable in Solidity. And this is how we declare them. We give it a type followed by the variable name. That's because Solidity is a statically typed language. That means that we have to declare the data type that's going to be stored in the variable, and it can't change. So if you come from some dynamically typed programming language, maybe like Ruby or JavaScript or something like that, where this could be a string, it could be an array, it could be whatever, it can always change. That's not how it works in Solidity. You have to only use the same data type anytime you assign this variable a value. So in this case, it's an unsigned integer. That just means that it's a number that does not have a sign. So a signed integer could be negative, for example, like -2 would be a signed integer with a sign in front of it. This is an unsigned integer, does not have a sign in front of it. So it's always positive. That's what an unsigned integer is. Now, there's different kinds of unsigned integers in Solidity. This could be uint 256. You can see all the different possibilities here. This could be uint 8, right? 88, 80, 184, 48, 248. All right, and this is just referring to the number of bits that the integer can contain, which is going to determine the size. So by default, they're 256. You can customize this to be smaller if you want, but for now, I'm just going to use uint 256, and I'm going to use uint for short. So this is going to be the count inside the smart contract. And I should also note that this is a state variable, So the value of this variable is going to get written to the blockchain. So anytime we update this value, it's going to get stored on the blockchain like a database. And this is really similar to like an object relational mapper or something like that in another programming language or framework where you might be reading and writing from a database and have an object that is responsible for updating a certain column in the database. That's how this state variable works inside of Solidity. Essentially, this count is going to get stored on the blockchain, and this is the variable that's in charge of reading and writing that value of count on the blockchain. So let's create a way to set this value. We're going to do it like this. We'll say function increment. All right. So this is how you create a function inside Solidity. You use the function keyword followed by the name of the function, and then you follow it with an open and closed parentheses. If it had some arguments, we could put some arguments inside of here, but in this case, we don't. And then you use curly braces, open and closed, and you put all the function code inside of here. All right, it works just a lot like any other programming language that has functions. You should be pretty familiar with this if you come from any other language that has them. Okay. So we can change this value pretty easily, right? We could say count equals count plus 1, right? That would just increment the count or change it by 1. We would just access this value and then add it back into itself. We can also do this with a shortcut. We can say count is plus equal 1, just like that. So that will change the count like this. Okay. So I want to do one other thing while I'm here. That will successfully increment the count, but I want to show you something that Solidity smart contracts have. In addition to functions and these data types and the variables and all that kind of stuff, it also has events. All right, so I'll show you what that is. So we can create an event inside the smart contract like this, event increment, and we will do this. Say uint value. All right. And I can call this event inside here just like this. Say emit increment, and then pass in count, all right, followed by a semicolon. So all these lines in Solidity need to be followed by semicolons just like this to let Solidity know that you're going to a new line. Obviously, we don't have to do that with functions because the curly braces are self-explanatory. Okay, so what is this event doing? Well, Solidity and Ethereum allow you to subscribe to events to smart contracts. So essentially, we can call this function, and anyone on the blockchain can subscribe to this increment event and find out that the count actually went up. Okay, so basically, anytime this increment function happen, we can listen for it, maybe inside of an app or any other service on the web or something like that that's going to listen to the blockchain and know that this function count happened, right? And it doesn't matter whether we called it or not, anyone can listen for this. And we can also find the history of these events on the blockchain from an event stream and stuff like that. It's pretty cool. So it's pretty powerful just to add this to your functions whenever you're programming smart contracts. I do it a lot in professional projects, especially for histories and things like that. Okay. So we can also create a function to decrease the count like this, a function decrement. All right. And we can, say count equals count minus 1, right? Or we could do the shorthand just like we did a minute ago and say count minus equals 1, and that will also decrement the count. And we can create an event for that just like this. Say event decrement, and say uint value. And that's going to allow anyone to subscribe to this decrement value in order to do the same thing they did with the increment. If anyone wants to find out that this value went less, they can subscribe to this event. It doesn't matter whether they call the function or not. Okay, so we can emit decrement. All right, and then pass in the count. All right, perfect. So now we want to be able to call these functions on the smart contract from our IDE. Now there's a problem. Currently, these functions can only be called inside the smart contract because they don't have any visibility set to them. So what do I mean by that? Well, we can't call this function from outside the smart contract because it doesn't have a visibility of public, all right? And we can do that just like this. All right. So these visibilities are things we can add to functions to tell Solidity where the function can be called. Inside the smart contract, outside the smart contract, et cetera, et cetera. All right. So if we want to be able to change the count, we have to add public here. And likewise, we have to add public here. All right. Perfect. So now what I want to do is set a default value for this count, right? So I can do this with something called a constructor function. All right, so the constructor function is the function that gets run whenever this smart contract is initialized for the first time, or when the smart contract is created. That's the same thing, okay? Whenever it's initialized, it's created, it's deployed, it's put on the blockchain. Remember, smart contracts are code that live on the blockchain, and anytime we deploy them, we're actually updating the blockchain state and putting the code on there so that it can get run on the Ethereum virtual machine, okay? So I can create the constructor function like this. This is the function that's going to get run whenever it's deployed. Just call it a constructor. Okay, we don't use a function name or anything like that. We just use constructor. And we create the function like that. And then we also set the visibility to public, just like the other functions. And now we can set the value of this count like this. We can say, count equals 0. All right, and that's going to set the default value for this count whenever we deploy it to the blockchain. Now, I want to show you one more refactoring. That shows you, how to create a constructor function, how to do stuff inside of it. While we're here, I want to refactor. All right, this is a little long-winded, but it does show you how the constructor function works. So I'm going to set the default value of the count right here. Boom. We can do it inline without having to do it inside the constructor function. Both of these are fine, and I wanted to show you how the constructor function worked, but this is a simpler way to be explicit about how you're setting the count. And you could go ahead and change it to anything you wanted to. It could be 10, it could be 1, it could be 1,000. We're going to leave it to 0 for now. Okay. So let's go ahead and run this smart contract and test it out. I'm going to deploy it to the blockchain that's connected to this Remix browser IDE already. Okay, so I'll go to this Solidity icon here, and I'm going to choose the version of Solidity that I want. So I chose 0.5.1. I'm going to say 0.5.1 right here. Okay, this is going to match the version that we set in the file. And Solidity is the language, EVM, compiler default. This is just the version of the Ethereum virtual machine. We don't need to change this. All right. So we'll compile it and see what happens. All right. No warnings. That's great. If you see some warnings down here, it should have either some error messages or some warning messages. Just read those and fix your smart contract code to fit whatever this says. Now I'm going to, actually deploy this. So I'm going to deploy it to the blockchain that comes with this IDE. All right. So what you can do is click this icon right here, this deploy and run transactions. This is just an Ethereum logo. And it's going to give you several different environments. So you can use the JavaScript virtual machine. Basically what that is it gives you a JavaScript-based blockchain that runs in your web browser. And that way you don't have to install anything. You don't have to connect to a test network on Ethereum. You're going to do it right here. Okay. So I'm going to use that. And it also has 5 different accounts with Ether, right? Already. So you don't have to request Ethereum from a faucet or anything like that. You can just use all these accounts that have funds in them. And no, this is not worth anything on the real Ethereum network. Sorry. So let's go ahead and deploy it. I'm going to click counter, click deploy. And there we go. The smart contract was deployed to the blockchain. So we can see the functions that we created are exposed down here. So I can increment. Just like this. All right. Well, actually, tell you what, I just realized that I forgot one essential component. We forgot to create a way to read the count. All right. So let's go ahead and do that. I'm just going to create a function that says get count. Function get count. And this function is going to read the count back. Say view public. And so view here is telling Solidity that it's just going to return a value. So view public, and then I'm going to say return count. All right. And also I need to specify the return value. I say return uint. Oops, sorry. Had a little problem there. All right, so my bad, guys. I forgot to add this. So now we have a function that says get count. All right, and I'm also going to show you that we can use the get count like this, or we can also declare the state variable public like this. Uint public count equals 0. Solidity will expose a public function just like this that's going to be called count. So we'll see two functions, two ways to do it. Get count, you can write it out long ways like this, or you can do this shortcut where you can just read the count from the smart contract with a shortcut like this. All right, so let's go back to the compile, make sure it compiles correctly. All right, no problems. Go back to deploy. I'm going to click the trash can on this because I don't want to use that smart contract anymore. I'm going to keep this JavaScript virtual machine instance, click deploy. All right, now we see all the functions that we want. Increment, decrement, count, get count. All right, so increment, we'll go ahead and increment it, and we'll get the count. Boom, it's 1. And also we can, call the count function that was created by default like this, count. Boom, also 1. So we'll increment it again, count is 2, get count is 2, increment it one more time, count, yep, all right, it works. Now let's try to decrease it with decrement. All right, decrement. All right, decrement 3, decrement, boom, all the way down to 0. Perfect. All right, so both these functions work. Awesome. So congratulations, you just written your first Ethereum smart contract with the Solidity programming language in your browser. All right. So as I promised earlier in the video, I would show you how to do this with a different blockchain. So what you can do is use Ganache. If you've seen any of my other tutorials, or you're maybe have tried Ethereum development before, you have seen Ganache. So Ganache is a personal blockchain that runs on your computer, on your desktop. It's got a nice graphical user interface. You don't have to run from the command line or anything like that. I'll pull it up on my screen here. So Ganache is a blockchain a lot like the one that runs in your browser, and it has a whole bunch of free accounts in here that have Ether and things like that. So we can actually connect to the Ganache blockchain like this. Let's just do, let's see here. Let's do a Web3 provider and say yes. We got localhost port 7545. Okay. And then we'll deploy the smart contract just like this. And there we go. Boom. We can do increment, get count, increment, get count. Boom, there we go. We can see all the accounts here, just like that. So that's how you connect to your Ganache personal blockchain. Now you can also do this with an injected Web3 provider that would allow you to connect with MetaMask. All right, so MetaMask is the Ethereum wallet that runs in your Chrome browser right here. And this would allow you to connect to different networks. So you could connect to this with the Kovan test network. You could do the main Ethereum network. Let's see here. Let's try switching networks. Sorry, I had a little hiccup in my browser here. So you could deploy to different networks like the main Ethereum network. All right, let's go here. Let's do injected provider. All right, account, open MetaMask. Sorry, I have to open it and set my password. So you could use any network you wanted to. You could deploy the smart contract to the main Ethereum network just like this. You could do a test network like Kovan, right? And that's a way that you could access some other network to put the smart contract on. All right, so I hope you all like this video. Again, subscribe to the channel if you haven't already. Click the like button down below. And if you want to learn more about how to build blockchain technology, if you're serious about becoming a blockchain developer, you should join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.